You've seen those headlines, right? The ones that sound like they were ripped straight from a sci-fi movie, talking about parallel universes or hidden dimensions or even shortcuts through time. They're totally captivating. But is any of it real? Or are we just being told a really, really good story? Well, let's dig in and find out. Yeah, you hear claims just like this all the time. They're presented like it's a done deal, that the math is all figured out and these incredible realities are just out there waiting for us. It's an awesome thought, isn't it? But this is the big question, the one we really need to ask. When you read about these totally mind-bending ideas, are you actually getting a dispatch from the front lines of physics? Or are you being fed a compelling narrative that's, well, maybe more fiction than fact? To really get to the bottom of this, you have to realize that modern science isn't just speaking with one single voice. No, it's actually talking to three completely different audiences. And trust me, the story changes a lot depending on who's listening. Okay, first up, the money. Let's be real, modern physics isn't some hobby you can do in your garage anymore. It is a massive industry that needs a staggering amount of cash just to keep the lights on and, hopefully, keep the discoveries coming. And I mean, we're talking about multi-billion-dollar ecosystems here. Think about things like the Large Hadron Collider or the James Webb Space Telescope. These aren't just gadgets, they're huge, decades-long investments that need constant justification. So how do you keep that kind of money flowing? Well, you need big, exciting, almost poetic ideas. These grand theories about the nature of reality become essential tools. You need them to write grant proposals that pop, to keep your research team employed, and to capture the imagination of the public and the politicians who control the budget. Look, it's not some grand conspiracy. It's just about survival in a really, really competitive world. And this creates this huge gap between the story you tell to get funding and the day-to-day reality of the science, or exploring extra dimensions. I mean, that sounds incredible. It sounds a lot better than the quieter, more honest truth, which might be that in some of these areas, there hasn't been any new hard data for decades. One story gets the funding, the other gets the lab shut down. Let's look at a perfect example of this. You've probably scrolled past this one online. This incredible headline claiming that scientists actually managed to reverse time itself inside a quantum computer. It sounds like it changes everything. But what really happened? The absolute key here is the difference between a mathematical reversal and a physical one. What those researchers did was brilliant, but it happened entirely within their formulas and computer simulations. It was absolutely 100% not a physical reversal of time in the room around them. Think of it like this. What they did was kind of like hitting undo on a spreadsheet. Yeah, it reverts the information in the computer, but it doesn't make the coffee on your desk suddenly go back into the cup, right? Or it's like using math to figure out what a can of paint looked like before you mixed the colors. But the paint you're holding is, still mixed. No physical atoms moved backward. No laws of thermodynamics were broken. And this quote just nails it, doesn't it? The difference between a mathematical model and physical reality is everything. It's the difference between a cool calculation and an actual consequence in the world. When one becomes the other, that's when you should pay attention. And that sensational time reversal story is the perfect bridge to our second audience. This is where the PR industry swoops in, taking these really complex ideas and packaging them for us, the public, where the goal isn't just scientific accuracy, it's getting clicks. Seriously, so much of science communication today is packaged using the exact same playbook Hollywood uses to sell a blockbuster movie. You've got the dramatic headlines, the emotional what-if hooks, the over-the-top analogies. It's all designed to create a sense of wonder and make you share the story. And the result? Well, that crucial line between a real, peer-reviewed, hard-won experiment and a speculative, entertaining thought experiment, it gets incredibly blurry. They're both presented to us in the same breathless tone, making it almost impossible for a normal person to tell which is which. Which brings us to our third and final audience. This is the one that's usually hidden from view, the scientists themselves, talking to each other behind the closed doors of the lab. See, away from the grant proposals and the press releases, the vibe is totally different. In private, physicists are incredibly cautious. You could even say conservative. They see these grand ideas as useful mathematical models or fascinating possibilities, not as proven facts about the world. They know better than anyone that math can describe all sorts of things that don't actually exist in nature. Inside the lab, the world is governed by what you can actually observe and repeat. And in that world, time only moves forward. The universe only gets more chaotic, not less. Broken things stay broken. And as of right now, there have been exactly 0 confirmed experiments that prove parallel universes are real. So what's the verdict when you put all of this together? When you look at all 3 of these audiences? You see this massive disconnect. A disconnect between the beautiful things math can imagine and the hard limits of the physical world we actually live in. I mean, this table really says it all. The funding machine, it rewards big, spectacular ideas. The PR industry, it rewards dramatic stories that get you to click. But reality? Reality only rewards one thing: slow, quiet, painstaking, hard evidence. And because that last one is the least glamorous, it's often the one we hear about the least. And you know, it all comes back to this. This is the ultimate sniff test. The math can be gorgeous, the equations can be elegant, but until those equations produce a result you can actually see with your own 2 eyes, they stay in the world of ideas, not the world of physics. And what's wild is that this isn't even a new problem. This is a debate that goes back thousands of years to the ancient Greeks. You had Plato, who believed math was the true reality underneath it all, and then you had Aristotle, who said, nope, reality is what we can touch and see and measure. Modern physics is still caught right in the middle of that exact same argument. And that really gets to the fundamental truth here. Mathematics is like a sandbox for pure logic. It can build a perfectly consistent universe with 26 dimensions if it wants to. But physics isn't a sandbox. Physics has a boss, and that boss is nature. It can only test what the real universe actually lets it test. Because genuine discovery is already amazing enough. It doesn't need the extra fiction. So the next time you see one of those jaw-dropping headlines about breaking the laws of physics, what's the question you're going to ask? Are you going to ask if it's a mathematical model or a physical result? Because asking that one simple question, well, that changes everything.